Welcome to the JFK assassination, Do the Math, Part 4B. In this part, I begin the math that shows an alternative method that proves my placement of the three assassins on the Dow Tex building is correct. First, some of you have expressed doubts that the fatal headshot could have come from the Elm Street side of the Dow Tex building. This is because from the few available photographs, even the newer ones from the satellite that I have used, well, it just seems as if the angle is too sharp, and that would make the shot too difficult to be successful or even attempted. I understood this. So a few weeks ago I went to Dallas and took this picture. I was standing in the middle of Elm Street at the spot where the president's head was located when the fatal shot struck. As you can see, the Elm Street side of the Dow Tex building is an excellent place to shoot from. Plus, there are advantages to shooting from this side with a limousine this far away. The first advantage is that from the Elm Street side, one does not kill or wound the First Lady of Texas. Remember in Part 3C I stated that the assassins were trying to kill President Kennedy and Governor Connally with the same bullet? Well, as the limousine progressed down the street, the farther to the left President Kennedy became in relation to Governor Connally. Eventually, Governor Connally was no longer in the line of fire, and Mrs. Connally would have been. And because the fatal bullet was fired from the Elm Street side, had Mrs. Connally not pulled her husband down upon her lap, he would most likely have been killed or at least wounded by the bullet from the fatal headshot. The second advantage is that a shot from the sixth-floor window of the school book depository building, or the Houston Street side of the Dow Tex building, at that distance should have killed or wounded the driver. And that is why the assassins had to be in two very different locations, one location on the right and one location on the left. Okay, now that you know this shot is not only possible, but actually preferred, let's do the math. By the way, when I'm referring to any shot, I'm referring only to a shot that struck a victim. Now, if I have placed all the assassins in their correct positions, then by using the angle of the wounds, the speed of the bullets, the speed of sound, and the speed of the film, one can predict in which frames of the Zapruder films the bullets were fired, in which frames the bullet struck the victims, in which frames one can see the reactions of the victim being struck by the bullet, and in which frames the physical reactions of Mr. Zapruder to the shots were recorded. And most importantly, this will demonstrate that all the frames were mathematically linked. In other words, from the action recorded in any one frame, all the other frames that involve a shot being fired can be predicted. Additionally, I will check these results against the speed of the vehicle as a double check. First, since all the assassins were the exact same distance of each of the victims on all shots, it might seem that Mr. Zapruder would also be the same distance from all the assassins as well. And for shot number 3, this is the case. However, for shots 1 and 2, this was not the case. By using a radius arc, I found out that while the distance to Mr. Zapruder from the first two assassins was the same, the distance for shot number 3 was a longer distance. This gap is approximately 15 feet, which means that Mr. Zapruder was 295 feet from the first two assassins, not 310. Additionally, Mr. Zapruder was located on a hill or knoll above the motorcade. Here are two pictures that will give you some perspective. From the intersection of Elm Street and Houston to the overpass is 488 feet. With the 3-degree slope of the road, at this distance the road has dropped vertically 24 feet. This means at a distance of 230.8 feet from the intersection, plus adding in his height and subtracting the height above the road the victims are at, Mr. Zapruder's ears are approximately 12 feet above the victims. To find the distance from the rifle to Mr. Zapruder, we must adjust the height. By subtracting the 12 feet from the 80 feet, we have a vertical height of 68 feet. Then we plug this into the Pythagorean theorem as line A, and this results in changing line C, which is the distance from the rifle to Mr. Zapruder, to 303 feet. Now we can do the calculation to find out how much time it took for the sound to reach Mr. Zapruder for the first two shots. To do this, we take the distance from the rifle to Mr. Zapruder and divide that by the speed of sound. Now the speed of sound varies and is dependent on the temperature of the air. The temperature that day was 65 degrees, which means the speed of sound was 1,123 feet per second. The distance from the end of the rifle to Mr. Zapruder was 303 feet. 303 divided by 1,123 is 0.269813 seconds. To find the correct frame when the sound reached Mr. Zapruder for each shot, we need to find the number of frames exposed while the sound traveled. To do this, we divide the time the sound traveled by the speed of the film, and we get
4.905691 frames.
Now we can find the frame in which the sound reached Mr. Zapruder for the first two shots, which I will show you in the next segment. The length of time it takes to do the calculations and check against what was expected for each shot will take too long to fit in the remainder of this segment. Thanks for watching.